Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.10, Problem 28. This is Section 2.10, Problem 28. We have the square root of 4 over 9 plus, in parentheses, 4 over 6 minus 1 over 4. Now, this problem has parentheses. Any type of math problem, if you have parentheses, you need to deal with those parentheses first. Now, in this case, notice the 4 on top, 4 on the bottom. You cannot cancel those. You might be tempted to, but it's not a multiply in between. It's a subtraction, so you cannot just cancel the 4s. What you have to do the work in parentheses first. You need to make a common denominator in order to do that subtraction. So the square root out in front of the parentheses, I can leave that for the next step or so. But now, in the parentheses, if I need to make a common denominator and I'm dealing with 6 and 4, a reasonable common denominator would be 12. 6 divides into 12 evenly, 4 divides into 12 evenly. So let's make them both something over 12. Now, for the 4 over 6, what's the numerator? So if I look at the denominators, the original denominator of 6 times some value became a 12. So it must have been times 2. 6 times 2 is 12. So the numerator must get multiplied times that same value of 2. 4 times 2 is 8. So 8 over 12 is the same as 4 over 6. It's an equivalent fraction. Same process for the 1/4. I want to make a denominator of 12. Compare the denominators first. So 4 times some value became a 12. That value must be a 3. 4 times 3 is 12. So the numerator is multiplied times that same value of 3. 1 times 3 is 3. So 3 over 12 is equivalent to 1/4. Now I can finish my work in parentheses. I have common denominators. I can do the subtraction. So I will have 4 over 9 plus the work in the parentheses winds up becoming 5 over 12. And that comes from combining the numerators. 8 minus 3 is 5, and you keep the common denominator the same. It was 12. Now what I have is an addition and a square root. So in terms of your order of operations, square root is like an exponent. So the square root must be done before the addition. So square root of a fraction you can think of as two separate square roots. Square root of the top, square root of 4 is 2, because 2 times 2 is 4. Square root of the denominator is square root of 9. Square root of 9 is 3, because 3 times 3 is 9. And I leave the other fraction plus 5 over 12. So I did the square root. Now I only have an addition left. I have 2/3 plus 5 over 12. And again, to do an addition, I need to have a common denominator. The 3 and the 12 have to have the same denominator. Well, 12 will work. 3 will divide into 12 evenly. 12, of course, divides into 12 evenly. So let's make them both something over 12. And I'll deal with the second fraction first just because it's easier. If the denominator got to stay 12, the numerator will stay the same. It'll stay 5. But the first fraction, I did something to the 3 to turn it into a 12. What I did was I multiplied times 4. 3 times 4 is 12. So the numerator gets multiplied times that same value of 4. 2 times 4 is 8. Now, to finish the problem off, I have 8 over 12 plus 5 over 12. So for an addition, I keep my common denominator. So the 12 will stay in the denominator. Combine the numerators. 8 plus 5 more is 13. So I have 13 over 12. Now, the 13 over 12 is what you call an improper fraction because the numerator is larger than the denominator. Now, some math teachers are just fine with that sort of an answer and you're done. You can leave it that way. Other math teachers like you to convert that to what's called a mixed number with a fraction. So if that's the case, what you want to do is take the denominator, in this case 12, divide it into the numerator, again for this particular problem, 13. 12 goes into 13 once. 1 times 12 is 12. The remainder is 1. 13 minus 12 is 1. So the number that you get as an answer is the number in front. The remainder is the numerator. The denominator stays the same. It was 12. Stays 12. So your answer can be written as 13 over 12, or if you prefer, 1 and 1/12. And that's the final answer for this whole problem for number 28.